Okay, hello. So today we're going to start on page 23 in our interactive notebooks for some vocabulary. Let's zoom in. Unit B, vocabulary proportional relationships we saw yesterday. Remember, they cross through the origin, so they always have the point 0, 0 and form a line. Let me zoom out a little so that you can see the rest of that. They cross through the origin and they form a line. They can be written in the form y equals kx. So, for example, y equals 2x, y equals 1/2 x, and y equals negative 5.3x are all examples of proportional relationships. Those are very special lines. They only are the ones that cross through 0, 0 because 0 times anything is 0. Today you will see the word input, the value we choose to replace x with. So input is the x. So I'm going to highlight that in matching colors. That green doesn't want to work. So input is the x. And then the other word there is output. Output is the y. It's the result or the answer we get after plugging in a value. So we have input and output there. We're going to see input-output tables. Two more words. We have initial value. The initial value we'll see today is the output when x is equal to 0. So the initial value is when x is 0, otherwise thought of as our starting amount. So yesterday, or with proportional relationships, 0 always meant we started at 0, but today we're going to see some other ones. And then the final word there that I'd like you to fill in is unit rate, the amount that the y changes for every one change to the x. So it's change in y over change in x. If you've never seen this notation before, this little triangle here in front of the y and in front of the x is delta, and it's read change in. So it's change in y over change in x. And it's the amount the y changes for every one change to the x. So we'll see unit rate show up today. But in other words, whatever comes after the 1 in an ordered pair. All right, on to lesson 2B. Again, if you needed to pause that, you were definitely welcome to, or go back and pause and write all those vocabulary terms. Let's look at lesson 2B today. So students will be able to interpret linear relationships that are not proportional. Today, students will be able to explain in words the process of determining an equation using the correct vocabulary, proportional relationship, equivalent ratios, constant of proportionality. And this is important for many real-life problems, like figuring out the amount of time to do a job. All right, so let's look at number 1. Isaac earns $8 per hour at his job. We should be able to write this situation in a table of values, figure out the ratios, the unit rate, and then finally an equation to go with it. So if he earns $8 per hour at his job, that means after 0 hours of work, he has earned $0. After 1 hour of work, he would earn $8. 2 hours of work would get him $16. 3 hours would get him $24, and 4 hours would get him $32. So if he earns $8 per hour at his job, that's how we can figure that out. The ratios here, we just take the change in y over the change in x. So the change in y from 0 to 8 would be 8 over the change in x is 1. And it should be equal to all the other ratios. Let's go from 0 to 16. That would be a change of 16 over a change in x. That would match, that would go to 2. If I go from 0 to 24, that would be the ratio of 24, and the one that was across from that was the 3, so 24 over 3, and that should still be equal when I go from 0 to 32, put 32 over 4. So let's think of those. 8 over 1 equals 8, 16 over 2 equals 8, 24 over 3 equals 8, 32 over 4 equals 8, and so the unit rate is the one that was out of 1. The unit rate is $8 per 1 hour. So the unit rate is the one that is out of 1. So the unit rate is when x was equal to 1, or in other words, right here. So that's our unit rate. And if we think initial value, our initial value was where it started at 0. So for our equation, we would write out that y is equal to 8 times x. And we could even put in a plus 0 here because it started with $0. So if Isaac starts with $0 and then earns 8 hours or $8 per hour at his job, that's how we can think of this. Now that was in labeling the hours as x and the amount he earned as y. So he started with $0, there's our starting amount, and then our unit rate the change was that he earned $8 for every 1 hour he worked. Now in a table, we're going to use that table of values to graph. And so you see that they already have the graph done for us here. And let's just check the graph. It looks like, let's see, 2, 4, 6, 8, 10. So it looks like they went by twos for the amount he earned. And over on our x-axis, the number of hours, they went by ones, 1, 2, 3, 4, 5. So yeah, they went by ones there, went by twos on the y. And so we see 0, 0 is here. And then we look at after 1 hour of work, he earned $8. So there's our unit rate. That's our unit rate right there. After 1 hour of work, he earned $8. So that's our unit rate. And then if we want to look at the starting amount, the initial value, we can see he started right there with $0. So he starts with $0. So we could put a plus 0 here. We really don't need a 0 at the end. We could write y equals 8x and call it a day. But there could be a 0 there to show that he started with nothing. Now notice this graph. What's different about this graph? Well, this one starts on a different amount. So starts with a different amount. So what is that amount? 2, 4. Looks like it's halfway between 4 and 6. So it looks like he starts with $5 there before he keeps saving. So let's see. He saved from there 2, 4, 6, 8. After 1 hour. So that one's a little bit of a different one. We'll see on the other side. So this equation was graphed. Y equals 8x was graphed on the first graph right there. Y equals 8x was graphed there. Now let's look behind this to see that other equation. You'll see that graph from the front is matched again. Now it's a little bit different. Isaac has some money before he starts working. So Isaac currently has $5 and then he earns $8 per hour at his job. So after 0 hours of working, he already has $5. Okay, but then he's going to keep working from there. So what about after 1 hour of work? Well, he's going to add $8 to this, right? So he adds $8. So now he's got 13. After 2 hours of work, he gets another $8. And so now he's going to have $21. 3 hours of work is another $8. So now he's got 29. 4 hours of work, another $8. So now he's got 37. All right, so those are our ordered pairs now. Notice this one starts up here at 5, and then we go up $8 per hour after that. Now our ratios are still going to be looking at the change in y. So we're still looking at the change in the y over the change in the x. So we're still looking at how much his money changed for every additional hour of work. So change in y over change in x means it's adding $8. So our change in y is $8 for every 1 hour of work. Okay, or if we skipped, for whatever reason, if we skipped a line on here and focused on after 2 hours of work. So after 2 hours, let's see, he earned $16 more after 2 hours, and that's all equaling our unit rate, which is $8. He's still getting $8 for every 1 hour of work. He's still getting that unit rate, $8 for every 1 hour, but this time he just happened to start with a different starting amount. So this time his equation, he started with $5, so we could write, starts with $5 and then earns $8 per hour after that. We could write it that way. Or we could write y equals $8 per hour plus the 5 he already had. And that's actually the more common way we'll see this. So here's our starting amount. Let's see. I'll highlight my starting amount with orange. So here's our starting amount. That's our initial value. Our initial value was 5. He started with $5. He currently has $5. And then he saves, or he earns extra. Then he earns an extra $8 per hour at his job. So he gets an extra $8 for every hour he works. And we figured out that $8 because we were adding 8 for every 1 hour of work. Adding 8 for every 1 hour of work, and so that went there. And so we see this increase by 8 for every 1 hour. So it goes up 8 over 1 hour, up 8 over another hour, up 8 over another hour, up 8 for another hour of work. And so that's how we would write our equation. Our unit rate ends up right here multiplied by the x because it's happening for every single hour he works. And our initial value is written over here. We added that onto what he was gaining. All right, so let's try another one of those. Courtney is collecting coins. She has 2 coins in her collection to start with and then plans to add 4 coins each week. So after 0 weeks, she already has 2 coins. So I'm going to be starting at 2. So I'm going to go up here. Here's my 0. There we are, 0. And she's going to start up here with 2 coins already. So that's my initial value. There's my initial value. That's my starting point. So initial value is 2. She starts with 2 coins in her collection. Let's highlight all those. And then she adds 4 coins each week. So after the first week, she's going to add 4, so she gets to 6. Then she's going to add 4 for the next week to get to 10. Add 4 to the next week to get to 14. So every week she's adding a week. Every time she adds a week, she's adding 4 more coins. All right, so let's think of what this would look like here. 1, 2, 3, 4 for 1 more week of work. So let's label our x-axis as time. That's our time in weeks. And our y-axis is number of coins. All right, so we're just going to be putting a few on here. So again, I went up 1, 2, 3, 4 for 1 week, up another 1, 2, 3, 4 coins for another week, up another 1, 2, 3, 4 coins for another week. And so I'm just going to label up to, 3 weeks there. And this does form a straight line. This is a linear equation because it forms a straight line. It's got that constant changing rate. We're going up 4 and over 1 every single time. All right, so there's our ordered pair. So our equation, we're going to use our unit rate and our initial value. All right, so our initial value here, she started at 0. 0 weeks, she already had 2 coins. And our unit rate was she added 4 coins per week. 4 coins per week. And so for our equation, let's just use y and x, or we can change out those letters, but for this time we'll use y and x. X is the number of weeks, y is the number of coins. So for our equation, that tells me she started with 2 and then added 4 coins per week for every single week. So that's where we see our unit rate. Our unit rate, again, shows up right here in front of the x. That's what we're multiplying by. And our initial value was added to start with, or added on. All right, so she already had 2, and then she added 4 per week. Another way we could write that, if we want to call number of coins C and number of weeks W. Can you see that? There it is. If we call coins C and weeks W, then C could equal 4 times W plus 2. So that would be another way to write it. All right, let's go ahead and look over here at some that were already done for us. Let's go ahead and look down here at number 6. So this one is very much like the last ones that we saw yesterday, where we are plugging in values for x into a pre-done equation. So just remember, I'm not going to go through every single one of these, but remember we would rewrite the equation 14 minus 2, and then we'd plug in each of the values for x. So 14 minus 2 times 0 is the first one we're going to plug in. So that would be 14 minus 0, which is 14. So input 0 would output 14. Input 1 means we would take out this x right here and we would put in a 1. So 14 minus 2 times 1 would mean 14 minus 2, which would give us 12. So right here, input 1 outputs 12. And next, let's just look at the 2. So 14 minus 2 times 2 would mean 14 minus 4, which would give us 10. And we could plot the points from there and look at our unit rate and initial value. So remember, for initial value, we want to look at the table for where x equaled 0. So our initial value is right here at 0, 14. Our initial value would be 0 goes with 14. And our unit rate is our change in y over the change in x, change in y over the change in x. And let's look at that. So the change in y looks like it looks like it was going and subtracting 2 when they were adding 1 to the x. And so that change in y over change in x would be negative 2 over 1, which is